Assalamualaikum dan hai semua. So hari ni kita masuk lecture on non-parametric test. So bila kita sebut non-parametric test adalah bermaksud test yang kita jalankan apabila data tersebut adalah tidak normal, which is non-parametric. Okay. Macam sebelum-sebelum ni, we have done statistical analysis on parametric tests such as ANOVA, t-test, Pearson correlation. So that is all parametric tests, okay? Because they are first normally distributed, they are homogeneous, and the measurements are on interval or ratio scale, okay? So basically, when all these assumptions are met, we will use parametric tests. But what will happen if those assumptions are not met? Maksudnya apabila data tersebut tidak normal. Jadi bila data tersebut tidak normal, what we have to do is we use non-parametric test. Okay? For example, when the assumptions are not normally distributed, the data are inhomogeneous, and the data measured are in ordinal scale, so we use non-parametric test. So if the parametric test we use Pearson, when the data is not normal or non-parametric, we use Spearman correlation. So there's no equivalent test for chi-square. And then if you use independent t-test, okay, the substitute for independent is Mann-Whitney test. For pair t-test, we will use Wilkinson test. And for one-way ANOVA, we have to use Kruskal-Wallis if it is a non-parametric test. Sorry, if it is a non-parametric data. Okay, so you have to remember all this. So if it is an independent sample t-test, the replacement or the substitute for t-test is for independent t-test is Mann-Whitney. So the hypothesis for the Mann-Whitney is basically the same as independent t-test. So H0 is median 1 is equal to median 2. But if you remember, independent t-test we use mean. We did not use median, okay? Because this is non-parametric, so we have to report it in median. Alright? So median 1 is equal to median 2, right? Which means there is no significant difference between median 1 and median 2. So for the HA, which is median 1 is not equal to median 2, or we can say that there is a significant difference between median 1 and median 2. Okay? So how to run Mann-Whitney? So we open two independent sample t-tests, and then we choose the Mann-Whitney here. Test of type, we choose Mann-Whitney. So after clicking the options, click continue. And then we get the results here. So for the output, we will not use the descriptive statistic because this is consists of the mean. What we have to do for non-parametric tests, we have to report the median and IQR, inter-quarter range. So we will not use the mean and standard deviation. So you have to run explore and then get the median and IQR for your results. Okay. So now we look at the result. Okay, so the result shows that it is 0.216. So 0.216 is less than 0.05. So when it is less than 0.05, we reject hash null. So when we reject hash null, it means that there is a significant difference between these two groups. Okay, Mann-Whitney can be also manually calculated by using the ranking. So, but this part will not be appeared in your final exam or in test 2. This is an additional knowledge for you that you know when Whitney can be manually calculated. Okay, let us see this example of this YouTube. So this is, they have two groups, treatment A and treatment B. So this is the formula for doing Man Whitney. So you have to calculate U statistic, which is equal to rank sum minus n in bracket n plus 1 divided by 2. Okay, so first of all, you have to know how many data are they. So here we have 12 data, 3, 4, 2, 6, 2, 5, 9, 7, 5, 10, 6, 8. After that, we list all the data based on the ranking. So first, because we know that they have 12 data, so we put 1 until 12 here. Okay, so and then we rank them. So the first number, which is the lowest one, is number 2. 2, and then the second comes with another 2 because there are 2 here. So number 3, the following number, so the following rank is number 3. All right. For the following number after 3 is 4. Right. And then we do this until the end of the data. All right. So the last number is number 10. Right. So when we what happen is when there is a tie number, for example, the rank for number 1 and number 2, there's this similar number 2 and 2. So what we do is we divide this one plus 2 and divide by 2. So we got here 1.5 and 1. So we look here, we put this as 1.5, 1.5, and then you could see there's a tie also for ranking number 5 and ranking number 6, 5, 5. So what we have to do, 5 plus 6 divided by 2, we got 5.5 and 5.5 here. Alright, because we need the value of the ranking. Once we finish all of the ranking value, we put the rank value besides the data. So for example, number 3 here, so it is ranked on the number 3, so we put it here. Number 4, it is ranked on number 4. So number 2, the data of number 2, it is ranked at 1.5. The rank is 1.5. So we put the ranking number here, 1.5. So once done putting the ranking value besides the data, we calculate the sum rank. Okay. So the sum rank for group A, we add all the ranking value here. So 3 plus 4 plus 1.5 plus 7.5 plus 1.5 plus 5.5. We all together is 23. And for group B, the rank sum is 55. So we plug in the number value in here. So first of all, we calculate the U stats for group A. So the rank sum is 23. 23 minus n, which is the number of the data, which is 6. 1, 2, 3, 4, 5, 6. So 6 in brackets is plus 1 divided by 2. So it is equal to 2. So U stats for group B is 34. Alright. So we choose the lowest U stats, which is U stats for A, number 2. And then what happens is we have to calculate the U critical. So U critical, we have to use the table. So we choose the group A have 6 and group B also have 6. So 6 here, and then we could see 6 here, and then we choose critical value at 0.05. So the number that we have here is 5. So the critical value for this Man Whitney is 5. Therefore, we write it down. U critical is equal to 5. So U statistic is less than U critical at alpha 0.05. So when it's less than U critical, when U statistic is less than U critical, we reject hash null. When we reject hash null, it means that there is a significant difference between treatment A and treatment B. Okay. Okay, now class, it is Wilkinson sign rank test. This is for PAT test. So what you have to do is go to non-parametric test and choose related sample. Okay, because they are related, they are dependent on one another. So set the significant level, check assumption, and justification for Wilkinson is that they are dependent, they involve small sample size and not normally distributed. So you choose the Wilkinson test type. So when you look at the output, you get the significant value at 0.000. So 0.00 is less than 0.05. So we reject H null. It means that there is significant difference between before and after, right? So it must be reported in median IQR. So, and then we have Kruskal-Wallis test. Kruskal-Wallis is a one-way ANOVA. I mean, it's a substitute for one-way ANOVA. If the data is not normal, you have to use Kruskal-Wallis. If it is normal, you have to use one-way ANOVA. So it compares the medians of 3 or more groups. ANOVA is compared between means of 3 or more groups. Alright? So you go to non-parametric test and choose independent sample, K independent sample. Okay? So this part you will learn in your practical lab, alright? So look at the chi-square, because Kruskal-Wallis is a type of chi-square test also. So look at the value, which is 0.000, which is less than 0.05. It means there is at least one significant difference between one group. So when we want to know which pairs that give the significant difference, we need to do the analysis, the comparison by pairs separately using Mann-Whitney test. So to reduce the type 1 error, what we have to do is by doing Nonparametric correction. So for example, like let me show you here. So the p-value that you obtain from the Mann-Whitney test, okay, for example here 0.14, you have to multiply it by 3, and then when you get the number, for example 0.042, you have to compare it with 0.05. Is it less or is it more than 0.05? So for example, when you compare BMI less than 20 with 20 to 29, you run the Mann-Whitney, and then you get the p-value. For example, you get the p-value which is 0.14. You multiply it by 3, and then you compare it with 0.05. Okay, so why do we multiply it by 3? Because there are 3 groups, right? So this is done to reduce the type 1 error. Okay, or you can also compare the p-value by 0.05 divided by 3. So the significant level is 0.016. It's either both. Okay. So this is the summary of the statistic test for today. Thank you, class. We're going to continue for chi-square after this.